Hi guys, today we are going to talk about the physical and chemical properties of the main group element. And guys, please don't forget to subscribe to my channel and please share this video to your colleague who is also a student so that everybody can pass this was okay. Thank you.
Introduction. Physical and chemical properties of the representative main group elements clearly display periodic character. As mentioned earlier, the metallic elements lie to the left of the diagonal band in the periodic table. The nonmetals lie to the right and semi-metals lie in a diagonal band between metals and nonmetals. Thus, as one moves from left to right in any row of the periodic table, the metallic character of the element decreases. However, as one descends down a column, the elements tends to increase in metallic character. In this lesson, we will take a look at the physical properties of the representative elements and the reactions of some of the elements with water. Objectives. By the end of the lesson, you will be able to 1. Explain the pattern and physical properties of the alkali metals and alkaline earth metals, semi-metals and the halogens. 2. Explain the chemical reactions of some of the elements with water. Relevant previous knowledge. You have learnt the introduction to the periodic table. Alkali metals are soft and have a silvery appearance. Cutting a bar of sodium with a knife is like cutting into a bar of cold butter. They all have a body-centered cubic structure, and are ductile. It can be drawn into wires, malleable, can be hammered into sheets, and conducts heat and electricity. Figure 14.1. Cutting a bar of sodium with a knife is like cutting into a bar of cold butter. Alkali metals have lower boiling and melting points than any other group of metals. Their densities are also lower than most metals. The soft nature, boiling and melting points of the alkali metals is attributed to relatively weak metallic bonding. This is because they have only one valence electron, Ns1. The weak metallic bonding means that the crystal structure of the alkali metals can easily be broken down, and this results in the soft consistency and low melting and boiling points. Sodium has a melting and boiling points of 98 oC and 881 oC respectively. The relatively low densities of the alkali metals are due to the lowest molar masses in their periods and large atomic size. The density of sodium is 0.968 gcm3. The alkali metals are highly reactive metals. They are powerful reducing agents. Because of their extreme reactivity, they are not found in nature as free elements. They react with water. Sodium reacts with water in the following reaction: 2 Na S plus 2H2O, 1, 2 NaO, Ac plus H2, G. The alkali metals form some useful compounds. For example, NaCl is used in the industrial production of NaO, Na2SO4 and NaCO3. NaO is the most important industrial base used to make bleach. Alkaline earth metals. The alkaline earth metals are relatively soft. However, they are much harder than the alkali metals. They are also denser. Density of Mg is 1.738 gcm3, stronger and have higher melting and boiling points than the alkali metals. This is due to the fact that there are two valence electrons, Ns2, available for metallic bonding, and the nucleus also contains extra positive charge. Thus, the attraction between the nucleus and the electrons are greater compared to the alkali metals. The melting and boiling points of magnesium are 649 oC and 1105 oC respectively. They are better conductors of electricity than the alkali metals. This is due to their two valence electrons. Compared with the alkali metals, they are less reactive. However, they are also too reactive to be found as free elements in nature. The alkaline earth metals react with water to form alkaline solutions. Magnesium reacts with water at a slower rate. However, it burns in water vapor to form magnesium oxide and hydrogen gas in the following reaction: MgS plus H2O, G, MgO, S plus H2, G. Semi-metals. Metalloids are used in semiconducting materials that occur in digital watches, radios, television, calculators and desktop computers. Figure 14.2 digital watch. Figure 14.3 desktop computer. A semi-metal or metalloid has properties that are intermediate between those of metals and nonmetals. It has the appearance and properties of a metal but chemically behaves like a nonmetal. Semi-metals tend to be less malleable than metals but not as brittle as nonmetals. Semimetals include boron, B, silicon, C, germanium, Ge, arsenic, As, antimony, Sb, and tellurium, Te. The semimetals lie along the staircase line on the periodic table. They are mostly brittle solids having some properties of metals and nonmetals. Their electrical conductivity is intermediate between metals, good conductors, and nonmetals, non-conductors. All the semimetals are solids at room temperature. The bond in silicon is network covalent. C has a higher melting and boiling point of 1420 oC and 3280 oC respectively. The density of silicon is 2.34 gcm3. Silicon is a shiny, blue-gray solid with a diamond structure. It is used to produce microprocessor chips. Halogens. They exist as diatomic molecules, with the exception of astidine, with the general formula of X2 internal metals. The halogens are diatomic molecules which interact through dispersion forces. The dispersion forces increase in strength from fluorine to iodine. As a result, fluorine, F2 is a pale yellow gas, chlorine, Cl2 is a pale greenish, yellow gas, bromine, Br2 is a reddish, brown liquid, and iodine, I2 is a purple, black solid. Figure 14.4 Colors of the elements that make up the halogens. Chlorine, which is a gas at room temperature, has a melting and boiling points of -100.98 oC and -34.6 oC. The densities of the elements as liquids at a particular temperature are increased steadily with molar mass. They are also insulators and do not conduct electricity. The halogens are very reactive. This is because of the presence of 7 electrons in their valence shells. It must gain 1 electron to fill its valence shell. They react with water. Chlorine is soluble in water and some of it disproportionate Cl2, G, plus H2O, L, HCl, Ac, plus HClO, Ac. All the halogens are toxic, but chlorine is used to sterilize water. Iodine and Ke is added to NaCl to prevent goiter. Summary: alkali metals are soft and have a silvery appearance. They all have a body-centered cubic structure, and are ductile, malleable, and conducts heat and electricity. The alkali metals are highly reactive metals. The alkaline earth metals are relatively soft. However, they are much harder than the alkali metals. Compared with the alkali metals, they are less reactive. A metalloid has properties that are intermediate between those of metals and nonmetals. The halogens exist as diatomic molecules with the general formula of X2 internal metals. They are very reactive.